If your Wi-Fi is on, your battery will drain very fast. Can we have a Wi-Fi chip which can run for 10 years on a battery? If my communication platform is not robust, and if it takes like 3-4 hours for the electricity to come back, how will you feel as a customer?
Very bad, matlab.
So that is what is happening.
What is the core problem you guys are solving?
So we implemented 802.15.4, which is one of the IEEE standards. I was part of the team who was implementing the world's first Zigbee stack. So we have a network interface card, a hardware piece, electronic board we get manufactured, which goes inside the meter. Now that piece makes the meter smart meter.
And where is this implemented? Today we have someone who has been solving a problem of network solutions from past 25 years, and today he is a founder of a company called Comminent, Amarjeet, and who's also a vice chairman of a IEEE committee which is 802.15.4. Welcome Amarjeet, how are you?
All good. Thank you very much for inviting me here. Looking forward to very deep discussion.
Yeah, definitely. Because the number which I already told in itself is a vast history. We'll come to that 802.15.4. It took me so much time to memorize that. But coming to that, before that, can you please tell me about your journey as a individual? How did you landed up into all this IoT solutions, network solutions, everything what you have been doing today? And obviously it's a 25 years journey. If you can walk us through about your journey in a brief, that from where you came from, where the companies you worked.
Right. So I'm basically from Bihar and did my studies in St. Xavier's College, Ranchi, and then landed in Karnataka for our engineering. Right. So Karnataka used to be the hub for engineering colleges. So I landed up in Karnataka, did my engineering in electronics and communication, and that's where the communication piece came along with the electronics piece, right? So when I got into job way back 2000, the early days of my job, 2004 or 5, where I was working in a company where I got introduced with, my company actually got a project where they had to implement the 802.15.4. So I got that standard. That standard was still under development, right? So we got the early access of that standard and we started implementing those standards. So I got introduced to those wireless communication system during those days. So we implemented 802.15.4, which is one of the IEEE standards. At that point of time, I was the implementer of that standard. And slowly, we also got into another industry consortium, industry alliance called Zigbee Alliance. So I was part of the team who was implementing the world's first Zigbee stack at that point of time. And also we were very active in participating in the interoperability events. So what happens is whenever a new standard is being written, we get like early adopters of 5-6 companies, right? So they implement those standards and then all of these people meet at one place. Once you meet there, you basically try to talk one device to the other device. Your device is talking to my device is talking to your device. And we try to find out if there is any different interpretation of the standard so that we can go back and correct the standard. So it is basically, these are the phases before the standards is available for the public. So I got involved into those, attended various interoperability events for Zigbee, tried to give my input on the standards, how to make it interoperable. And that's where the journey started, right? So I did 15.4, then I did Zigbee. Then I joined a startup called Gainspan. It was an Intel spin-out. We were doing low-power Wi-Fi chipsets. So that's where I got into how a low-power Wi-Fi chipset, because Wi-Fi...
What is this actually, low-power Wi-Fi chipset?
Yeah, so Wi-Fi, everyone knows Wi-Fi, right? So a Wi-Fi is very power-hungry. So if your Wi-Fi is on, your battery will drain very fast in your phone, right? Because Wi-Fi drains the battery too much. Our objective was to use Wi-Fi for battery operated devices like a sensor network, where I put a battery and put a sensor and it can keep transmitting data for, let's say, 10 years. Can we have a Wi-Fi chip which can run for 10 years on a battery? That was our objective, and that's what we wanted to do, and we did it. So we had our chipset, which was running for 8 to 10 years on battery.
On single charge.
Single charge. Yes. So that's what we did. And that's where I got into how the semiconductor works, because we were a chip company, right? So we were designing the chipsets. And I was kind of looking after the customers in Asia, US, Japan, Korea, all those places. So that is how my journey evolved. And in 2009-10 timeframe, I quit my job and I started my first company. And that's where I kind of started meeting people in Japan, in Korea, US. And the primary work what we were doing in the company was to the standards what we are writing in IEEE or other standard bodies. We were implementing those standards and providing it to our partner companies. For example, if you want to build a chipset and a new standard of Wi-Fi is coming, because you would have heard Wi-Fi A, B, G, N, there are so many Wi-Fi 6, Wi-Fi 7. So every day the standards evolve. You keep getting new and newer version of the standard. Now, when you get a new standard, you need a new hardware, you need a new chipset. The chipset doesn't work without a software stack, right? So we were providing that software stack for the standard which is being developed right now. So it is kind of an early mover kind of a work, and we were partnering with the chip vendors, providing our software to the chip so that together we can go and sell the chipset in the market, to the module vendors, to the solution companies. So we provided to more than 20 companies over 10 years. So I ran that company for almost 9 to 10 years. We had offices in Japan, US, and India, and I was kind of heading the whole technology part within the company. So that's how I moved forward. On the standard part, I also was part of another alliance called Wyson Alliance. We started this alliance in 2011 in Japan, and this was more from a large-scale IoT solution company perspective. Basically, if you look at Wi-Fi, today you go and buy any Wi-Fi chipset, it doesn't matter, right? You can just go buy Cisco, Netgear, Linksys, it works. You don't even think about it. As long as it is a Wi-Fi, you just go and buy it, right? And it works. How does this happen? There are a lot of story behind this. As a consumer, we don't know about it, but there are a lot of steps we follow in order to arrive there, right? Ethernet or any other thing, right? You just buy product and it works. What happens is you develop a standard and then you develop a test and certification plan, and then basically every company implements that, goes back and makes sure that their products are implemented in a similar way. So there is a whole lot of process, standard development, then the interoperability and compliance comes into the picture, then the product comes into the market. Now, Wi-Fi is like a home area network, right? So personal area network, within home, within office you do. But in past 15 years, we are talking a lot about IoT, Internet of Things. Everything has to be connected over internet. As long as your product is inside home, you have various network like Wi-Fi, Ethernet, you can connect and do. But what if your product is out on the street, spread across the city? The use cases like smart city, smart grid, smart metering, any other municipal applications like a street light. How do you basically make a network where all of these devices across vast area can basically talk to each other and make a network? We have one option is cellular, but cellular have its own limitations, the shadow network availability and things like that. So today, if you don't get a cellular network, you kind of walk to the balcony and you get your network. Now, taking a smart meter, now that is fixed on the wall. They can't go on the balcony and get a network, right? So you need a network which is dynamic, which can find if there is a dark patch, can I reroute the whole network? Can we have a self-healing? Can we create the network dynamically, change the configuration of the network? Now, that was the need of our, and there was a lot of development across the world happening, being done actually by various companies, and all of those were proprietary. So the proprietary solution provided by these companies what was happening is the utilities or the end customers were getting logged in, that once I have taken the solution from you, I can't go to anyone else. And then I am at your mercy. If you say my price goes up, it goes up.
Okay.
Right? My product is not available, then you wait for the product to be available, then only the next set of devices can go in the field. Right? So that kind of a problem had started coming. And at that point of time, 2011-12, government of Japan, some utilities in US, some of the utilities in Japan also, they kind of pushed the industry to create another alliance. What objective of this alliance was to, or is to create an interoperable solution for this large-scale IoT network, right? And that's where Wi-SUN Alliance got formed. Wi-SUN Alliance, the full form is Wireless Smart Ubiquitous Network. And I happened to be one of the founding member at the time of when it was getting formed. And that's where I got more involved into the standards in day-to-day affairs. Also, the standard which I first developed 2004-5, I got into an opportunity where I had to go to IEEE standard, and the standard which I was implementing in 2004, I got an opportunity to write some of the sections of contribute to that standard. So I became one of the co-author of that standard. And when I was doing that, I also figured out that till that point of time, I was not involved much into the Indian ecosystem. So when I was doing in IEEE, I found out that in India, the frequency spectrum used for these applications, sub-gigahertz, 865 to 867 megahertz, was not part of any standard, any of the standard, which means that India didn't had their frequency spectrum part of any of the standard. So I kind of opened up a new project in IEEE, and I was the vice chairman of that, the standard which you mentioned, 802.15.4U, which is specific for India. So what we did is we took the spectrum available for Indian ecosystem by the Wireless Planning Commission, Government of India. I took that standard and made as a part of the, took that spectrum and made as a part of the standard.
So where is this standard being used? Like, for example, to like in India, like wherever we can see it as a normal audience.
So any IoT product which is working on sub-gigahertz is where this standard is being used. Today, all the RF mesh-based solution across India is using this spectrum. Any LoRa devices which we are using in India is using this frequency spectrum. However, LoRa doesn't use this standard, but it uses the frequency spectrum. So any IoT products which wants to use this frequency can use this spectrum actually. So I would say easily more than 10 to 15 million devices today in India is operating in this frequency spectrum. Some may be on this standard, some may not. So it depends on how you have built your product. So that's how I got involved into these standards, and I started getting involved into Indian ecosystem. I got involved with Department of Telecommunication, TEC, Telecom Engineering Center. I wrote a couple of papers there to kind of push for getting additional frequency spectrum for IoT market segment in India. Also, I got part of Bureau of Indian Standard, where we had to create one new committee, and this was driven by Modi's this smart city, right? So we got like 100 smart city during the first tenure of Mr. Modi ji, and what we found that all the smart cities were not being done at the pace at which we were expecting, right? So we wanted to find out the reasons, and one of the reasons identified during 2019 conference was that we lack on various standards. We don't have standards to follow for these smart cities. What are the reference architecture to be used? There was no reference architecture. So that's where the Ministry of Housing Urban Affairs, Government of India, requested BIS to create a committee to work on those gaps. And that's where I was involved into that whole exercise, and I was given a responsibility to work on the communication piece. So I still be the convener of that committee, panel 1, where we work on communication technology, what communication technology to be used for smart city and overall a smart grid or smart solution for large scale IoT. So that's where I kind of, and then did a lot of other things.
As of now, today in Comminent, actually, what is the problem statement on the core level you guys are solving? Like, and in terms of our, like, for example, we as a consumer might not see in a day-to-day objective or a day-to-day basis, but somewhere or the other, it is might be interconnected with us also.
Yes.
What is the core problem you guys are solving around? And I think you've been running for 3-4 years. You've been started this company.
Yes. So when I was running the previous company, which I closed in 2019, what I found out when I got involved with Indian ecosystem, how I found out is and specifically for smart metering, I'm talking about the utility companies or the or the metering company. They are great at metering. They know anything you ask. They know in and out. They are the masters.
Smart meters.
Meters.
Okay, only meters.
Meters.
The electricity meters.
Electricity meters. Okay. The transmission, how the transmission happens, how the distribution happens. They're great. I will not be able to just say anything on that. But when it comes to smart metering, anything, when you say smart, what does it mean?
You should be smart.
No. So what exactly, how things is made smart, right? So you have a product or a services which you are already providing. For example, metering. The metering companies are selling electricity for ages. They know how to sell the electricity, collect the bills and things like that. Mm-hmm. Existing infrastructure, you introduce a ICT framework, information and communication technology.
Okay.
The moment you introduce the ICT, what happens is your physical infrastructure which is deployed in the field we are creating a digital twin on a digital platform.
Correct.
So which means that, for example, we are sitting in an area in Bangalore. In this area, let's say we have 1 lakh meters.
Okay.
Can I go and see the meters every day? No.
No.
But if I give you a platform where all the 1 lakh meter is visible,
so you do not go to the entire.
You don't have to go to the place, right? So what we did is we created a digital twin. Okay. It's a twin, right? So whatever is there in the field, you can see on a digital platform.
But in that perspective, you do not change the meter.
No. You will have to, there are 2 ways. There are retrofitting also can be made, but that is not that reliable.
Okay.
So generally we change the meter.
Once the meters are changed, 1 lakh meters in one place, a person will not come to my home to take the reading in every month.
Not only that. So what happens is the utility can now see the whole system on their dashboard. And if any meter doesn't have power, they get notification immediately. You don't have to call the metering office saying that, boss, my electricity has gone. Can you please come and correct? Right? Because the problem would have been multiple reasons, right? One could be just your home electricity has gone, or it could be that whole road electricity has gone. You have a transformer, right? So distribution transformer. So from where you have like around 100 house connection. If all 100 has gone, something is a problem with the transformer. So they will not wait for all 100 people to call. They will immediately know that all 100 electricity has gone. So the problem is at transformer. So the time it takes to service the consumer is reduced drastically because of this. Right? So when I looked at the smart metering and how it is being done in India, as I said, they're great at the metering, they're great at distribution, electricity, they know everything. But when it comes to communication, they lack the expertise. It has improved drastically from that time till now, but still it lacks on a greater deal. Now, what I also see is that what is being deployed is needed. Basically, what was the suppliers who is supplying the components for making it meter smart, the communication piece, they are selling what they have. They are not selling what the utility needs. Utility needs X, I have Y, I'll just try to convince you that you need Y and you sell it. Now that is a recipe for disaster. It will work for a certain period of time, but after that it will not. Because you will get into some kind of a problem. It will not solve certain problems. You would want to basically, I'll take one example. Like we have a prepaid meterings coming, right? So it is like your prepaid mobile phone.
Correct.
So you pay 100 rupees, you get 100 rupees. After that, this one is cut, right? So here also we have a prepaid metering. Now, if my meter has been, my credit is exhausted, right? So my meter is disconnected. Now I'll go back and charge my meter. Now I want the electricity immediately.
Auto recharge.
Auto recharge. If I have recharged, my electricity has to come back immediately. If my communication platform is not robust, and if it takes like 3-4 hours for the electricity to come back, how will you feel as a customer?
Very bad, matlab.
Right? So that is what is happening. So the solution what they have put, if that is not designed in a way to handle these kind of a use cases, you will see this problem.
And that's somewhere you guys solved something.
So what we did is we said we want to focus only on the communication solution, and that's where we said we will provide an end-to-end communication platform which takes care of all these use cases.
So for example, if a smart meter is already in place, from that place to the central space, all the areas, all the meters, you will be providing that communication platform.
So we provide the communication device which goes inside the meter.
Okay.
We create the network across the city.
So this meter will be a smart meter or a normal meter?
It is a normal meter which has a place where you can insert the communication device.
Okay.
We call network interface card.
Okay.
So we make the network interface card which goes inside the meter. All these meters creates its own network.
Okay.
Every meter is talking to each other, and finally we have a data concentrator unit, which is the brain in the field sitting on the ground, and which connects the whole network to the backend system. So I was telling you about how we basically build the network. So we have a network interface card, a hardware piece, electronic board which get manufactured, which goes inside the meter. Now that piece makes a meter a smart meter, right? All these meters is connected with each other. It talks to each other and creates its own set of network. And then finally we have a data concentrator unit which has the local brain which collects all the data from all the meters and then sends it back to the server, right? And on the server we have a network management system which basically manages all these millions of devices on the field. So that's how on very high scale I can say how the network is being formed there.
And where is this implemented? Is the कहीं पर ये implement हो चुका है and ये कैसे work करता है? मतलब on ground में like as a customer do I need to pay something else extra or कौन bear करेगा cost?
Okay, so there are two questions. One is how the whole business there and where we are working right now. So in India, the government of India, Ministry of Power have come up with a business model which they called AMISP.
Okay.
AMI service provider, Advanced Metering Infrastructure Service Provider. So what they are the one who gets the project from the utility, and we provide our solutions to AMISP because AMISP job is to get all the components together and build the end-to-end solution and deliver it to the utility.
Okay.
So our business is B2B. We sell it to the AMISPs, not to the government, right? Now, and it is the utility who is basically billing to the consumers. I'm not very sure, but there is no additional charge as such for the smart metering there.
This is an additional thing to ease our life from a electricity point of view.
It is from both sides. What is the business of a utility is to sell electricity.
Correct.
More you sell, good for us. If I sell more, which means that you are getting 24/7 electricity as a consumer. So you get benefited, utility gets benefited, right? So this basically infrastructure enables the utility to provide a better service, right? Which in turns allows them to sell more electricity. In turns, the consumer gets a better service and a more electricity. So it is a win-win for everyone, right? Now, where we are working, the second question you had, our first project we got where we are deploying in Gujarat. UGVCL is a utility where our solution is being delivered today. Also, we are doing with some private players. We are doing some installations in Hyderabad in private apartments. It's like 60-70 floor apartments, and every floor have 3-4 flats, and every flat have multiple meters. So we are doing a vertical integrations also. So we are doing multiple solutions there.
Interesting. This is one particular sector जो मुझे पता नहीं था कि ऐसा भी कुछ segment है. For meter के लिए भी there is a device now. मतलब
Yes.
ऐसा मैं बोल सकूँ तो apart from meters you guys will expand to some other thing कि ये कार्ड जो आपने बनाया है and obviously there are two ends card and the platform the software जिस पे सब कुछ दिख रहा है
Yes.
this card can be used in other part also.
Yes. So our platform, when we made, we said we want to make a large scale IoT platform. Along with large scale, I would also say that all these applications also falls under critical infrastructure, right? When I say critical infrastructure, it is a network where you cannot compromise, right? For example, if someone hacks into your network and shut down all the electricity, what will happen to the city? Right? So these kind of application where we work is a critical infrastructure, and security becomes one of the key parameter for those solutions. Our solution, when we built, we wanted to build it for a uniform network where we can have multiple applications. Our solutions can be used for any kind of a large scale sensor devices like street lights. So smart street lights can be done with the same platform. Gas meters, water meters, any smart city applications. So these are more of a kind of a utility or kind of applications. We can also do industrial IoT, where within the factory, if we want to create a network and various data parameters we want to read and monitor, we can do that. We can use it for agriculture. So the application has no limit. It's like you have Android, how many apps you can develop. So it's your choice where and how you want to build. So as long as it meets the requirement, our data bandwidth and other things what we provide as part of the network, if your application meets your use case meets our solution meets the requirement, then you can use it. No problem. So today we are working on smart metering, we are working on water meter and street lights, and we are looking forward to work on other applications also.
Interesting. But on the overall Indian point of view, like if this gets implemented, say suppose in every city as of now, if this metering part, will it save energy consumption also? Like will the like वो भी एक बहुत बड़ा टॉपिक है ना कि energy consumption is a very big topic these days.
Yes. So two way I would want to answer this. One is the answer is yes. The whole reason why we are doing this smart metering. India is the 6th largest economy in the world, and we have aimed to become the second, or God willing, we want to be the first, right? So, and when you say we want to grow the economy, there is a energy consumption is directly proportional to your growth of your economy. If you want to grow, you have to have more energy consumption, right? And that's where we are talking about nuclear power plant and other things creating more energy, right? It's because you need more energy. Correct. You want to run more and more manufacturing, you need energy. Without energy, you can't do. Now, generating energy is not going to solve all your problem. Generation is one part, transmission is the other, and the last leg is the distribution. Now, if you are bleeding at every stage, you generate, let's say, 100 unit, right? And at the end, if the consumer is getting only 50 and 50 is being lost during this, how are you? Generation, transmission, distribution, right? Okay. So during this whole journey, if you are losing your energy, then how are you going to sustain? It's
and
not
generally
sustainable.
How it happens? We are actually losing 50%.
Not exactly 50, but there is a big portion of electricity getting lost during transmission and distribution. There are other issues like theft and other things, right, in the rural area. Now, with this kind of platform, at least on the distribution, the last leg where we focus is basically we can actually monitor and find out where the energy is leaking, whether it is because of theft, whether it is because of the faulty equipments, and so on and so forth. So that is one of the reason when you know things, right? When you know that I am losing here, you will go and correct it. If you don't know, then you will not correct it, right? So one reason of doing smart grid is this also. The whole smart metering and smart grid, the reason is also to use the energy resources and optimize and reduce the losses. And that in turns helps us making it green, because if I want to use 100 unit and I end up generating 200, I'm losing 100.
Correct.
Right? If I am doing it optimally, let's say I generated 100 and I could use, let's say, 95.
That's
right?
the main actually.
So we end up generating less energy, right? So which in turn saves a lot of this also. And also not only that, so basically what happens is you are running a factory, for example, and if your electricity is down, and today the turnaround time is, let's say, 4 hours to get that electricity back, your production is stopped for 4 hours. What will you do? Either you will go back to your generator where you are running on diesel, or if we have these kind of a grid where we can reduce this turnaround time from 4 hours to, let's say, half an hour, your 3.5 hour production is saved. So everything is linked. It is more going towards sustainability, reducing the carbon footprint, and everything is linked there.
Interesting. And over the time, actually, anyone else is doing this in India? First of all, I want to.
Yes. So when we look at the communication piece where we work, right, there are two major communication technology which is being used for this, and one is the cellular technology. Now when you talk about cellular, all the communication modules we are getting is out from outside India, right? Some of these players have started manufacturing in India, but the IPR and the technology is still from outside India. And please remember, I said we are in a critical infrastructure. And in critical infrastructure, if your technology is coming from outside India, you are at risk, right? So that is one piece. The second piece we are talking about is a RF mesh network where we work, right? We work on cellular also. So we do all kind of a communication technology, but primarily we are focusing on RF mesh because we see less number of players in India today, not only in India, globally. So RF mesh is the second technology where we have few companies trying to do that. All of those are proprietary in nature. We are the only company in India who is working on a standard-based interoperable RF mesh solution and 100% made in India. Whether it is a hardware design, whether it is an embedded firmware, we are writing inside the chip, or whether it is a cloud application, whether it is the manufacturing of those hardwares, everything is done 100% in India. We are the only company. Now, when you look at the global landscape, right, so there are only 4 or 5 companies globally who have this end-to-end solution available. And we will be only the second, third, or fourth companies across the globe who is independent of the meter or the end devices, right? Okay. So we are independent company. We are not linked with any specific meter company or a street light or this. So we are independent communication platform.
Card can go to any meter which is being manufactured in India, or like any specific thing gets changed as per the manufacturing of the meters.
Correct. So every meter in India has to adhere to BIS standard 16444, the standard which we will have to follow. But unfortunately, that standard doesn't say that the size of the NIC card, the placement of the NIC card is not defined. Okay. Which means that every meter manufacturer is making their meter and the placeholder for the NIC card is on their own wish. Okay. As we speak today, we have a standard today which is work in progress. It is available for public review, right? And we are hoping that it will be published very soon.
It will have a same size.
We'll have a same form factor, same number of pins, same power factor, everything same.
Then for even if you manufacture the same kind of chip every time, and it can be get into any kind of a meter. As of now, you might be making as per the demand what you have been receiving and the contract what you get.
Yes, yes. So that also we are progressing in that direction.
What? So you have been like, this is super interesting because this is something which for me also is very new. And like for energy, this is what energy space which looks like actual. Like it's been 15 years for you, like you have been running company, first company and the second company. What kept you going for so long? Because this sector is not very exciting, I would say. For example, from a startup perspective, where founders see day-to-day basis, it's a very big problem. But people have glorified few of the segments. This is very deep level understanding, required a lot of knowledge, lot of background, lot of research, everything. What kept you going so long and so patient enough to reach here? as an individual?
Right. So when I started, when I was in college, right, as I said earlier, I was talking to you, I had registered my first company in when I was in college, but
2001, na?
2000, year 2000.
2000.
Yes.
That time company registration was easier or difficult?
Um, Not very easy, but not very difficult.
Okay.
But we did that. But we didn't do much because I didn't had any experience, and the area in which I was working, like electronics, not much of a. Now we electronics is the hottest buzzword in industry, but at that point of time, people were not looking to work in electronics, more on a software or a Java and stack and
correct.
cloud and so on and so forth. But I was more into electronics, and electronics always fascinated me. So when I started my company, the running a company and the entrepreneurship, that was always there within me. So I was always looking forward to do something on my own. And since my expertise over a time grew into communication, and I kept working on communication one after the other. What kept moving me is the problem. I love solving the problem. That is my forte. I am more a technical person than a business person. So whenever I get a technical problem, I love solving it. And I was working, as I said, in customers in Japan for 7, 8 years. 10 years. I visited 50 times to Japan, and every time I go there, meet to a customer, we got a problem. I said, okay, I'll solve it. So solving a problem is the motivation, and I wanted to always build something. I wanted to do something for India in India, and that's the direction I have been taking. I had my own ups and downs. I would not say that every day was a rosy and gloomy. There was always a day that should I do it or should I just quit?
What was that one moment in your life? जैसे for example मेरे में भी एक moment था कि अब छोड़ देते हैं, मतलब अब इससे ज़्यादा नहीं हो पाएगा, मतलब वो क्विट करने का रीजन यू हैव डेली, यू माइट बी गेटिंग वन रीजन कि छोड़ देते हैं, बट वो उतना बड़ा नहीं होता है, बट एक ऐसा समय आ जाता है कि अब छोड़ दिए तब नहीं होगा और
See, when you start something, leaving it is not easy, right? And I always felt like this is my baby. How can I leave this
Correct.
in between? I need to bring this to a level and then prove it that yes, this can be done, and then let it run on its own. So it kept motivating me, my team members. On my worst days, my team members were standing behind me, and I was like, I can't leave them in between. They have trusted on me. I can't leave them. So I kept going. I had my worst days where I didn't pay salaries to my employees for 6 to 8 months. And some of them stick to me, and they are still with me. So it is because of them we have been able to deliver this.
Interesting. Last one thing before we end, like today, and everyone, we are in HSR. The time when you came to HSR, it was not the same what we see today.
Yes.
I think 2011, na?
2005, I landed in HSR. I was in Bangalore before that.
But 2005, you came to HSR.
Yes.
20 years. 20 years before the place which we are in, it was not existed.
Right.
Today, everyone is a founder here. We see around more than thousands of startups being registered in HSR. Every corner, every cafe, every pani puri stall or tea stall, we have a word of startup. But eventually, people have not been that. Just you told, it's your baby. Like for me also, it is like कि अब 8 साल हो गए तो अब छोड़ने का मन नहीं करता है. एक समय आ जाता है कि आप अब नहीं छोड़ सकते हैं इसको. So for now, the people who are starting now, actually 2 years, 3 years, actually they become very impatient these days. So what is one thing which you want to say to the upcoming startup to solve bigger problems in the field of energy, climate, deep tech? Because these are the new things which we need to solve for India. And upcoming, which I see 2030-35 तक ये वाले sectors बहुत boom करेंगे.
Correct.
Because we need to do something in this sector: energy, consumption, transmission, जो भी बोलो, and climate, deep tech, healthcare, which is on the device level side. What do you suggest to new upcoming entrepreneurs who are doing now?
So as an engineer, we always tend to build something which is technically great.
Correct.
Don't build technically great. Take a small problem, make a solution in a very simplest way to solve it. Don't try to over-engineer it. I have done that mistake in past also. as an engineer, we can make marvels, but can I sell it to a consumer?
True.
If you cannot sell a product, and even if it is a genius product, it is going to get into a trash.
Correct.
Right?
This is where the most of the technical mind से कि हमने product बहुत अच्छा बनाया है, but वो बिक नहीं रहा तो का मतलब क्या है?
Correct. So don't over-engineer it. Make a product and don't try to bring too many problems at once. Try to solve one small problem and try to solve in the simplest way. And always think that when a product is going in my customer's hand, how he is going to look at my product. Is it going to be easy for him to use my product, or is it going to be complicated? Right? So ease of use of the product is very important. Understanding customers' mindset is very important. Don't try to over-engineer it. Don't try to put too many things and make it costly so that you can't sell it, because eventually, whatever you do, you have to sell it. Right? If you don't sell it, you'll have to set it. Right? So selling is important, and these things help keep the product in a right shape where you can sell it.
Interesting. With this, thank you, Amarjeet, for being on this podcast. One of the new thing which I learned today, because obviously this is not so common these days. And thank you so much for sharing the journey with us.
Thank you very much for inviting, and would love to share my thoughts anytime. No problem.
Done. Thank you.
Thank you.